All right. So picking up where we left off the other day, we finished at 26. So the next one say use the basic identities to change the expression to one involving only sines and cosines. So 28 sine of theta minus tangent of theta times cosine of theta plus cosine of pi over 2 minus theta. So what kind of what things can I rewrite?
Pi over 2 minus theta equals sine.
Okay.
So that'd be negative sine, right? Because it'd be sine minus theta then. Wait, never mind. I'm mixing up two properties. Don't never mind.
Oh
So
my
then-
gosh, I hate myself so much sometimes.
Let's see, hold on.
What else can I rewrite?
That's a good question. I'm not sure.
Could you divide one of the things from the other one with tangent and cosine? No.
How can I rewrite tangent? I want everything in terms of
Oh,
sine and
so-
I
cosine.
thought that was just tangent.
That's what I was thinking. But like, I don't know how to word things. It's like a bit hard. Oh great! When I did class watch.
So sine of theta divided by cosine of theta times cosine of theta. The cosines cancel.
See, that's what I wanted to happen.
So that leaves you with sine minus sine plus sine. So it just leaves you with sine of theta.
It's so easy when we're doing it with you now, and then I'll get to it, but then I'm like,
I'm not into it. That's usually how it is. But then sometimes I do something unexpected and I actually get a good grade. Yeah.
I did it. I just put it through.
Nice.
Simple.
I have. She was trying to
Get
get.
my history.
It's an
right.
open notes history test tomorrow.
And I didn't take like half the note, not half, like 1/4 the note.
I took them all. You
At
could
least she
choose
told you
mine.
it was open notes before the test.
Well, it's open note and it's book.
That's
And if she
And open
grades
chapter.
our receipts in time, then we get them back. But I know she won't because Brooke and I were the only two people that finished them yesterday because everyone else was.
Wow.
That he finished his. I was like, there was one other person. It
Yeah,
was
I was talking.
Chase is just super smart. I'm sorry.
All right, 32. Secant squared of x cosecant of x over secant squared of x plus cosecant squared of
Why are
x.
some of them squared and some of them aren't? I'm mixing it up.
well, you could probably change cosecant to 1 over
Wait,
sine. I
wait,
don't
is
know.
that wait?
I lied.
Is it a property thing?
No,
Secant?
because
No,
secant and cosecant aren't the same.
they're not.
All right, well, how can I rewrite secant in terms of sine and cosine?
Bye, friends.
One
Plus
over cosine.
So 1 over cosine squared of x times, how can I rewrite cosecant?
1 over secant.
1 over sine.
Sorry.
1 over sine of x
that would be the right thing.
all over, I can rewrite secant squared as 1 over cosine squared plus cosecant squared I can rewrite as 1 over sine squared.
Oh, you're multiplying and adding those are different. Keep change flip.
Not yet.
Yeah.
Alright, so on the top I'm going to have 1 over cosine squared of x times sine of x all over. On the bottom I need to get a common denominator, so how do I do that?
Keep change flip.
I need a common denominator.
Bye.
Common denominator. Oh, it's 1. No, that's no. You have to put them together first. You have to add them. You could change. Hold on. Sine. You could change sine. No, you can't do that either. Oh, I don't know.
Okay, if I give you this, how do you get a common denominator for that?
You
Multiply.
By what?
By 3.
Okay, the first one will get multiplied by 3 over 3, and the second one will get multiplied by 2 over 2. So if I want to do that for sine and cosine, how do I get a common denominator?
Cotangent. No. By each other. So like you multiply it.
The cosine one by
Cosine by
sine
sine and
squared
sine
of
by
x over
cosine.
sine squared of x.
And
that
now
one
it
would be
gives you
cosine squared.
cotangent.
So then on the top of that part, that's going to give me sine squared of x plus cosine squared of x over sine squared x times cosine squared x. Now, what's sine squared plus cosine squared?
1.
Wait. Why is the bottom sine squared x cosine squared x?
Because I got a common denominator. Now what?
Oh, I get it now. Never mind.
Dividing by fraction, so what? So 1 over cosine squared of x, sine of x, times sine squared of x, cosine squared of x. Cosine squareds cancel, sine cancels with the squared, so that leaves me with sine x.
Oh,
Alright, next one's combine the fractions and simplify to a multiple of a power of a basic trig function. So 34. 1 over 1 minus sine x plus 1 over 1 plus sine x. Ideas on what I should do there.
I haven't finished writing the other one. One minus sine of x, would that be cosine? Oh, it's only squared. It's only squared ones.
I know, that's what I was thinking too.
It says to combine the fractions. So if I want to combine the fractions, what do I need to do?
You have to have a
Like
same
denominator.
denominator.
Okay, so how do I get a common denominator then?
Multiply it
You
by
multiply the
-1. No.
you multiply the one on the left by 1 plus sine of x over 1 plus sine of x, and then you do the other one with 1 minus sine of x over 1.
So this one's getting 1 plus sine x. And this one is getting 1 minus sine x. So on top I have 1 plus sine x plus 1 minus sine x over 1 plus sine of x times 1 minus sine of x. Now what?
This might be totally not right, but you FOIL the bottom.
But it's a special type, so what is it?
1 minus sine x squared.
1 minus sine squared. And what do I have on top?
You just add them and subtract them and everything.
Well, signs
2.
cancel.
2.
The
just
ones,
two.
yeah.
2, and then what is 1 minus sine squared of x?
Tangent?
It's tangent.
Squared?
Squared.
No. It's cosine, dang it.
Yeah, cosine.
Cosine could be rewritten as what? Or what's 1 over cosine?
1 over.
Okay,
Secant?
secant. So this is going to be 2 secant squared of x.
Sweet. Cheese. Oh. I forget that's recording.
It's okay. It'll be comedy for Ariel when she watches it.
Yeah. Hey, buddy.
Oh, she lost
I'm
her
recording.
rage. By the way, I did make a mistake. Chase was, like, there were 3 people that finished it. It was before Chase and I.
Ariel, we miss you, and Hope is driving me crazy, and I need you to come back because I'm about to lose my mind.
Stop it.
I'm just kidding.
Sweet cheese.
But she's really not.
Yeah, but I'm really not.
I'm an angel. What are you talking about?
She was in a funky mood yesterday.
Me?
Yeah.
No, I wasn't.
Yeah,
A little
you
bit. What was I?
You just weren't like yourself. I don't
What?
know. You like were sad.
Sad?
It's like you were like serious Hope. You weren't like.
It's because we had that lab.
Well, our partner in crime's not here, so.
Yeah, exactly.
I was fine. I was fine. I did my work.
Exactly.
That doesn't mean I'm sad. Maybe I just wanted to be studious.
All right.
Like
What I need to do.
denominators, so you multiply the bottom one by 1
Plus.
plus cosine
Wait.
of x.
I
Sine of
hate
x.
this.
No, I would. Ignore me.
Just
I can't say cheese. The other
Oh.
one have to
no,
be
that one is
The other
multiplied by
one's
sine
sine
of
of
x,
x.
and then the
What
other
was
one
that?
is 1 minus.
I don't know how to
So on top, I'm gonna have sine squared of x plus 1 minus cosine of x squared.
Can we go ahead and.
Yes, I could FOIL if I wanted to. I'm just writing it that way for the moment. And then on the bottom, I have sine of x minus sine x cosine x. All right, so what do I need to do to the top? Or like with this piece specifically?
Sorry, I had you on first. You would FOIL the 1 minus cosine of x.
It's a special type, so what does that give me?
1 plus cosine of x squared.
The perfect square trinomial.
1 minus cosine of x? No.
Hold on, I need to look at it. Oh,
Okay, minus 2 cosine.
no.
Plus
Plus cosine
Cosine
of x.
squared.
This is not fun. This is not a good time.
Well, the x's can't. The signs cancel on the bottom, right?
Sine squared plus cosine squared is?
1.
So 1 plus 1 is 2 minus
Where did we get that?
Pythagorean identity.
Oh.
Yeah.
Oh, never mind. I get. Okay.
Now what I'm probably ultimately going to figure out is that I shouldn't have multiplied the bottom through, so I'm actually going to split it back into this. Because based on what I see on the top, most likely something will cancel. Now, what can I take out of the top?
The 2.
So 2 times 1 minus cosine of x over sine x times 1 minus cosine of x. Now what?
Can you multiply by 1 minus cosine of x on top and bottom?
You can get rid of it.
Get rid of it.
That'd be 2 over sine x.
Which is what?
There's that 1 over cosecant.
1 over sine is what?
So it'd be 2
It's
cosecant.
Yeah, so it'd be 2 cosecant.
My mom's gonna do it. he has to take my dad to the airport because my grandpa crashed his car a while ago and he has to borrow one of ours. Doing great, guys.
Alright, 40. Write the expression in factored form as an algebraic expression of a single trig function. I'm going to tell you, don't stress about this problem too much, but I want you to see it because it will come in handy in the future. So, 1 minus 2 sine of x plus sine squared of x. Now, it wants us to factor this, okay, like you would normally factor any quadratic function. You probably don't know how to do that with trig functions. So I'm going to teach you an easy way to do it. We're going to do what we call U substitution. We're going to let U equal the sine of x.
I remember doing this. We did this once. Because I didn't understand.
It'll come in handy in calculus.
Made me very confused.
It'll come in handy in calculus?
We're doing a lot of that right now. Alright, so anywhere you see a sine of x in this equation, you're going to replace it with a u. So 1 minus 2, oh, there's a sine of x, so I'm going to write it as a u. Plus, there's another sine of x, but it's sine squared, so u squared. Okay, if you're like me and like things written in standard form, u squared minus 2u plus 1. How would you factor that? It's a special type.
Be u minus 1 times u plus 1? No, it's squared. It's u minus 1 squared.
U minus 1 squared. Now, I use this substitution, so I need to come and plug that back in. So anywhere I see u, I'm going to replace it with sine of x. So sine of x minus 1 squared is my answer. Alright, next ones. Write each expression as an algebraic expression of a single trig function. (48) Tangent squared of alpha, or if you're in stats, fish, over 1 plus tangent of alpha, or fish. So what do you notice about the top?
It's technically a Pythagorean identity, but it's subtracting.
So it's not then.
It's not. Okay.
But what do you see in the top?
A fish.
Okay, something's being squared. If I were to rewrite this as, what would you tell me to do on top?
Take an x out? No, you can't do that. I don't know.
Looks like a difference of squares to me.
Yeah, so tangent of alpha minus 1 times tangent of alpha plus 1.
And then would you agree that tangent of alpha plus 1 is the same as 1 plus tangent of alpha for all practical purposes?
I can't draw this stupid fish.
So then I'm just left with tangent of alpha minus 1. If you can't draw the fish, I would just pick another letter. Now, that one, the Pythagorean identity didn't work, but it is definitely possible, so you always need to check them and make sure.
Yeah.
Because obviously it will make life a lot easier if it does work. So 50 tangent squared of x over secant of x plus 1. Look at, is there anything that I have here that can be written a different way that maybe includes something else that's in the problem?
Oh, well, tangent square root of x could be 1 plus 1 minus secant of x. Secant squared of x. But that might
Secant
not.
squared minus 1.
Yeah.
Yeah.
That's what
So tangent squared can be rewritten as secant squared of x minus 1. Okay, and that's good because that looks relatively similar to what I have on the bottom. Now, what do you notice about the top?
it's squared.
Difference.
So
Okay,
different.
much like 48, it is also a difference of squares now. So what would the top be?
Secant of x plus 1
Secant squared of it. Oh, never mind. Why did I say that?
of x minus 1
All over secant of x plus 1.
plus 1 and then cross off and then you have the secant minus 1. Secant of x minus 1.
Alright, the last thing is pretty easy. There's one note here that we didn't write when we actually did notes. The square root of trig functions must be positive. So they need to be written in absolute value bars. Okay, because obviously we know trig functions can give us out negative values, so that's why we have to take only the absolute value of them to get the positive ones. This is quite possibly the easiest thing in the whole section, so that's always good.
Sweet.
So 70, the problem is the square root of x squared plus 1. We're told that x is equal to tangent of theta.
Why didn't they just write it? Tangent of theta.
Huh?
Why didn't they just write tangent squared of theta?
Who knows?
Okay.
I don't care if you do that when you go to do it. It just, I don't know why they
So
did
would
it.
you just put it in for x, for x's?
So x squared is going to give me tangent squared of theta plus 1.
Which is equal to secant square root.
So the square root of secant squared of theta. Square root of secant squared would be
Wait, square root of secant. No,
Secant.
secant theta.
secant of theta. Because I can only account for the positive ones. I need to put absolute value bars on it, and I'm done.
Awesome.
That's so easy.
Alright, one more of these, and then we'll be done. 72. The square root of 36 minus x squared, x equals 6 sine of theta.
Okay, so you put the x in. So 36 minus 6 sine of theta squared.
And one thing just to note really quick is that all of x is being squared, so that includes the 6. Okay, so if you need to write it this way first, you can do that, or if you can jump straight to this step that I'm about to write, 36 minus 6 squared is 36, sine squared of theta, that's okay too. Now what?
So then it would equal to 6 minus 6 sine of theta. Right?
Just sign us.
Well, I can take a 36 out of both of these, right?
Oh, then it'd equal 1. Okay.
So 36 times
But it
1
equals
minus
the
sine squared of theta.
sine of theta.
1 minus sine squared of theta is what?
Sine.
So 36 cosine squared of theta.
And then can you take out a 6? So, wait,
So I can-
6 cosine of theta?
6 cosine theta. Because I'm not worried about whether the 6 is like positive or negative. I don't have to put it in the absolute value bars, but the trig function itself has to get put in absolute value bars. So it's 6 absolute value of cosine of theta.
Sweet.
Now, did I give y'all any problems the other day?
No.
No.
Said you would just wait.
Okay. Then I've got to. Alright, it's probably going to be a lot, but technically you have. I'm just going to say it's due next Monday, which I know is like really far away, but you have. I mean, there's still time today if you want to do that or if you want to work on something else. Tomorrow you have all of class. Thursday, everybody basically but Taylor is going to be in here, but Friday's junior, senior, so I'm just going to say it's due Monday. And that way you have plenty of time to do it. Because it's going to be a decent amount of problems because every problem is different, and so I want you to see a lot of them.
Practice
Um,
makes perfect.
So guys, don't forget your book on Thursday.
Mine's Monday.
Okay, guys.
11, 13,
I want to take it tomorrow.
19,
I don't think she'll let me.
23, 25,
I guess we'll have all of Thursday of study, so it's really
29, 31, 33, 35, 37, 39, 47, 49, 69, 71, and 73. So like I said, I know it's a lot, but that's why I'm giving you almost an entire week to do it. And you also have a surplus of class time to work on it, so.